So I just wanted to review with you guys some of the polynomial operations that we've been working on. So last week we talked about adding and subtracting polynomials and how we do that. We're also going to incorporate some of the vocabulary that we went through, that way just to kind of help answer a few questions that you guys had. So I'm going to jump into a couple of these examples here. The first one is find the sum of 3x squared minus 7x plus 4 and 2x squared plus x minus 1. So first thing here, when we have the word sum, we need to recognize that that's talking about addition. So this problem is really asking us to add these two polynomials together. So I'm just going to rewrite this as a math problem instead of a word problem and just bringing those polynomials down exactly the way that those are written. So what's really nice when we're dealing with addition is we don't have to worry about distributing anything. We're going to jump right into like terms. So when we're combining like terms, what we've got to be careful with is we're only going to combine the terms that have the same variable with the same exponent. For instance, here I have a 3x squared, and in my other polynomial, I have a 2x squared. So they both have x's that both have an exponent of 2. When I combine like terms, the only thing I'm adding are the coefficients, so the numbers out front. So 3 plus 2 is going to leave us with 5. And then we bring the variable along and keep the exponent. So it's going to stay at 2 for my exponent. Then I look at my next set. I have a negative 7x. And over my second polynomial here, I have an x. Okay, so they both have x's. They don't have a variable, an exponent other than 1. Right here, I'm going to make this into a plus 1x. Okay, that way I have two numbers to combine. So just like we did before, we're adding our coefficients. Negative 7 plus a positive 1 gives us a negative 6. So we've got a negative 6x. So that x is just coming along for the ride. Last but not least, we have our constants. So we have a 4 and a negative 1. 4 plus negative 1 or 4 minus 1 is going to leave us with a positive 3. So what we're left with is 3 separate terms, which would make this a trinomial because it has 3 parts. And something else that a few of you asked questions about is the degree. The degree means the highest exponent. So for this problem, our degree is 2. It's the highest exponent, or highest power. So then if we look at the second example here for us, we have a subtraction problem. It's already written out, so we don't have to worry about translating it from words into math. It's already written as a math or an algebra problem. So we have these two different polynomials, two trinomials, and we're subtracting them. What I like to do with these to help myself out is I put an invisible, or rather I take the invisible negative 1 there and I write it in. That way it gives me something to distribute into those parentheses. Okay, so this first set of terms here didn't change. Nothing changed, so I'm just bringing those down. In my second set, that's where I'm going to multiply each and every part by negative 1. Negative 1 times 7 gives me a negative 7x squared. Negative 1 times positive 2 gives me a negative 2x. And negative 1 times a negative 9 gives me a positive 9. So all of my signs changed. Once my signs changed, I can go ahead and just start combining like terms. So once again, I'm looking for same variable, same exponent. So 5 plus negative 7 or 5 minus 7 gives me a negative 2x squared. Then I've got my negative 4x, negative 2x, so negative 4 minus 2 or negative 4 plus negative 2, either way, we'll get a negative 6x. And then our last, we got a negative 1 plus a positive 9, leaves us with positive 8. So just like in the last problem, we have 3 separate terms. So again, we have a trinomial, and it also happens to be a degree of 2. We're going to be doing a lot of these types of problems in the next part of this unit in the next couple weeks. The last one here, these are the ones that sometimes we've got to be a little bit more careful with. It's the word problems when we're dealing with subtraction. So because where we're dealing with subtraction, the order matters. It's not commutative like addition or multiplication is. If we put these in the wrong spots, we're going to get a different answer. So we have to be very mindful of how we write these. So we want to subtract 16 minus x squared. Oh, a little binomial here. I'll just jot that down. Okay, so a binomial from this trinomial of 3x squared minus 2x plus 1. So when we're subtracting from something else, the part that comes after, that's actually what goes first in the problem. So before I start subtracting anything, I'm going to write this out as a math problem. So that trinomial is going first, and then we're subtracting this binomial, 16 minus x squared. So once it's written out, it becomes just like what we did above. So first thing, I'm drawing in that -1 in front of that second set of parentheses. That way I have something to distribute. That first polynomial doesn't change. Everything just comes down. -1 times 16 gives me -16. -1 times, oh, here's another -1. Negative times a negative is a positive. So I'm left with positive 1x squared. Now my signs are the way that they're supposed to be. I can go ahead and start combining. So I'm going to start with this one. I have my 3x squared. I have this x squared or 1x squared over here. 3 plus 1 is 4. 4x squared. I have this -2x. Oh, there's nothing else to combine with it, so that comes down. Last but not least, I have 1 minus 16. So 1 minus 16 leaves me with a -15. So once again, everything is written out. There's no more like terms, so that's my final answer. The other thing I just want to check and make sure that things are in standard form. So standard form just means that it's written from the highest exponent down to the lowest. And that was one of our vocabulary words from last week. Lowest exponent. So when I look at this one, my first exponent's a 2. It's not written in here, but this is really an exponent of 1. And then the last, I have my constant, which is an exponent of 0. So it's written in standard form because those exponents are decreasing. So the other operation that we started to look at, and we're going to do more with it next week, is multiplying. And right now it's just multiplying a monomial times binomial, trinomial, or something else. But it's a monomial on the outside and some other polynomial inside of parentheses. And that's where our good old friend, the distributive property, comes in. Okay, so when we're dealing with these types of problems, we're going to take this monomial on the outside and multiply it by both parts or all the parts of the polynomial inside of the parentheses. What we've got to be extra careful with is now we're dealing with all these exponents. So when we are multiplying, we have to remember to add the exponents. Okay, and that happens anytime, like any of your exponents that are attached to an x, you can add those with other exponents with an x. Same thing if it was y's, you can add y exponents with other y exponents. You just can't mix your letters, that's all. So for this one, as I'm distributing, I have 2 times, oh, this is a 1, so 2 times 1 is 2. And I have x squared times x squared, so I'm going to add my exponents now, and it's going to become an x to the 4th. Then this other part of it, I have 2 times -3, which gives me -6. X squared times, oh, this is an x to the 1st. So I'm going to fill in my exponent. 2 plus 1 is 3. So because these two do not have the same power, they are not like terms, so that is as far as we're going to go, and we're leaving our answer as that. In this next example, now we have a monomial on the outside of our parentheses times a trinomial inside. And sometimes what I like to do to help myself out is I'll fill in any missing exponents. So I have this 1 with this x on the outside, a 1 here, just so that way I remember that they're there and it helps me add them as I go through. So I have 5x to the first times 6x to the second. 5 times 6 is 30. 1 plus 2 is 3. So I've got 30x to the third power. Then I go to my next term. 5 times 4. 5 times 4 is 20. X and x, both to the first power. 1 plus 1 is 2. 5x times negative 2. Well, 5 times negative 2 is negative 10. And then this x, there's no x to add it with. It just comes along for the ride. So although this trinomial, once again, has 3 different terms, and they all have x's in them, they are not the same exponents, so they are not like terms. So we're going to keep it just as that. The last type of problem that sometimes we see with these, this one isn't crazy, and we have looked at ones like it early on in the year, is when we're asked to simplify and there's a bunch of parentheses in the problem. So what we've got to be careful of is exactly what are we multiplying into these problems. So I can see for this first set of parentheses, it's a 3 on the outside. So I'm going to multiply both of those inside terms by 3. 3 times 2x is 6x. 3 times negative 5 is negative 15. So I'm going to write down a minus 15. When I look at my second set of parentheses now, what I've got to be careful is this negative 2 is what's going to get distributed. So a negative 2 times a 6x is negative 12x. Negative 2 times negative 1 is a positive 2. So we just have to take this a step further. Not only do we have to multiply these out, but we want to simplify or combine any like terms that we have. So going back to what we did with our adding and subtracting, we want to just combine like terms. So we have the 6x, negative 12x, so 6 minus 12 leaves me with negative 6. And then x, I'm adding here. So my exponents are not going to change. They're going to stay the same. The last but not least, I have this negative 15 plus 2. So negative 15 plus 2 gives me negative 13. These are not like terms. One has an x, one does not. So this is as far as we can go. We wind up with a binomial. Now this one, sometimes with the degree, what we've got to be careful of is it does have a degree. It's just hidden. We know from previous problems that we just dealt with in number 4 and number 5 that when we don't have an exponent written in but there's a variable, that really there's an invisible 1 for that exponent, which means for this problem our degree is really a first degree polynomial or a degree of 1. So hopefully this answered a couple questions that you guys had. A lot of this was based on conversations that we had last week in our meets or some of the emails that you guys sent me. And as always, if you have any other questions, please let me know. But I hope this clarified some things. Okay, thanks guys.